Okay, so this video will explain further about subtopic 10.3, which is about physical properties of carboxylic acids. Let's talk about the first type of physical properties of carboxylic acids that you need to know, which is about boiling point. Bila kita cakap pasal boiling point, tak kisahlah pasal any organic compounds, alkene ke, alkene, alcohol ke, carboxylic acid ke. Bila kita cakap pasal boiling point, you need to remember about dia punya types of intermolecular forces, because from the types of intermolecular forces barulah you boleh elaborate sama ada boiling point dia tinggi ataupun rendah. Okay, so kita tengoklah contohnya you ada organic compound yang di mana dia ada functional group carboxylic acid ni ialah C double bond OOH. So we are going to focus at the functional group carboxylic acid ni, C double bond OOH. Okay, di mana kita tahu dekat this functional group carboxylic acids ni, mereka adalah polar molecule. How do you know it is a polar molecule? Because there is a difference in the electronegativity between carbon, oxygen, hydrogen. Okay, sebab oxygen is more electronegative compared to carbon and hydrogen. So it's a polar molecule. But how about dia punya type of intermolecular forces? Okay, the type of intermolecular forces adalah hydrogen bond. Okay, dia punya types of intermolecular forces dia adalah hydrogen bond. So kita tahu hydrogen bond ni dia punya intermolecular forces dia is much stronger than van der Waals forces. Okay, so kiranya dia mempunyai boiling point yang tinggi disebabkan dia ada type of intermolecular forces of hydrogen bond. And we know hydrogen bond ni kita susah nak break the bond. That's why dia punya boiling point dia tinggi. Okay, tapi kita tahu alkohol pun ada hydrogen bond. Tapinya carboxylic acids ni dia punya boiling point dia will always be higher than alcohol kalau mereka ada molar mass yang sama. Sebab apa? Sebabnya carboxylic acids ni dia ada stronger type of hydrogen bond. Okay, kenapa dia ada stronger type of hydrogen bond? Because dia boleh form dimer hydrogen bonds. Okay, this is the keyword. Inilah dia yang membezakan kekuatan hydrogen bonds antara alkohol dan juga carboxylic acid. Ini dia punya keywords. Okay, keywords dia ialah dia boleh form dimer hydrogen bonds. Okay, dia boleh form dimer hydrogen bonds. Ataupun kalau let's say you nak buat ayat, you can say that carboxylic acid ni dia can form hydrogen bond through dimerization. Penting ya ayat ni. Sebab nanti kalau let's say dia nak suruh kamu compare the boiling point between carboxylic acids and any other organic compounds, you can say that carboxylic acids will always have the strongest type of hydrogen bond is because it can form hydrogen bond through dimerization, ataupun you boleh cakap it can form dimer hydrogen bonds. Okay, so this keyword sangat penting. It will help you to gain marks in your kalau let's say you tengah examen, dia tanya pasal benda ni, this is like a very good points. Okay, so disebabkan carboxylic acid ni dia boleh form hydrogen bond through dimerization, that's why dia ada stronger type of hydrogen bonds. Therefore dia lagi perlukan banyak energy untuk overcome the stronger intermolecular forces. That's why lah carboxylic acids ni dia punya boiling point will always be the highest compared to any other organic compound. Okay, alright, so macam mana dia boleh buat dimerization ni? Dimerization ni is actually bila two hydrogen bonds can hold a pair of molecules together. Okay, so for example, ini adalah sepasang carboxylic acids kan. Dia boleh hold kedua-dua molecules ni, dia boleh buat dua hydrogen bond. Itulah maksudnya dimerization. Okay, sebab dia boleh buat dua hydrogen bond yang akan hold sepasang molecules ni together. Okay, lagi satu, kalau let's say the bigger the molar mass of carboxylic acid, sekiranya kalau lagi besar dia punya alkyl group ni, lagi bertambah-tambahlah tinggi dia punya boiling points. Because ni kita dah semakin kita besarkan dia punya molecular mass ataupun molecular size, dia punya molar mass pun akan bertambah berat sebab banyak carbon atoms. So lagi tinggi dia punya hydrogen bond just because of dia ada bigger contact surface area between the molecules. Okay, so let's look at the first example. Dia suruh kamu arrange ethanoic acid, metanoic acid, propanoic acid and pentanoic acid in descending order of boiling point. Explain. Okay, kat sini kesemua-semua organic compounds ni adalah carboxylic acid. So, bila you nak susun, lepas tu nak kena buat ayat pula tu, kena explain. Okay, you kena cari dia punya differences. You need to find dia punya differences. We know the similarities between them. Dia punya similarities dia, all of them are carboxylic acid. So kalau semua carboxylic acid, kita tahu dia punya type of intermolecular forces dia adalah hydrogen bond. Hydrogen bond through, dia boleh buat hydrogen bond through trimerization. Okay, so tak boleh gunakan point dia buat hydrogen bond through trimerization. So you kena find the differences between them. Apa dia punya differences? You tengok ni. This is S maksudnya ada 2 carbon. Okay, meth maksudnya ada 1 carbon. Okay, prop maksudnya ada 3 carbon. And lastly is pent. Maksudnya dia ada 5 carbon. So dia suruh kamu susun. As what I told you earlier, selain daripada faktor, kalau let's say ini ethanoic acid and then you nak compare dengan ethane, bolehlah you gunakan point hydrogen bond, van der Waals forces, okay? Macam carboxylic acid ni dia ada higher boiling point just because of dia ada stronger hydrogen bond and dia boleh buat hydrogen bond through dimerization. Tapi in this case, dia punya differences adalah bilangan carbon atoms. That's what I told you earlier. Lagi banyak carbon atoms, lagi tinggi dia punya, okay? Lagi banyak carbon atoms, lagi tinggi dia punya boiling point. Okay, sebab dia ada larger contact surface area. So macam mana you nak susun? Dia suruh kamu susun in the descending order. Bukan ascending order, descending order. So macam mana nak susun tu? Kalau descending order, you need to remember daripada boiling point yang besar kepada boiling point yang paling kecil. Okay, so descending order kan? So that's why it's going to be pentanoic acid yang pertama. Okay, sebab pentanoic acid dia ada 5 carbon. As what I told you, lagi banyak carbon, lagi tinggi boiling point kan? So pentanoic acid ada 5 carbon, so dia lagi tinggi boiling point. Nak susun descending order daripada kecil, daripada besar ke kecil tau. So pentanoic acid dulu, lepas tu baru propanoic acid, and then ethanoic acid. Propanoic sebab ada 3 carbon. Lepas tu ethanoic acid ada 2 carbon. Lastly is metanoic acid because there is 1 saja carbon. Okay, so how do you explain this? So you can say that pentanoic acid has the highest boiling point because it has the biggest molecular size. Okay, dia punya size dia besar sebab dia ada banyak carbon atoms. Therefore, dia punya contact surface area pun yang paling besar. Thus, the van der Waals forces between the pentanoic acid molecules are the strongest. Kat sini kita tak guna point hydrogen bond. Sebab kenapa? Semua carboxylic acid ni semuanya ada hydrogen bond. So, we don't use this kind of point. Kita gunakan points carbon yang banyak. So, kita tahu kalau carbon banyak, carbon is not about dia punya type of intermolecular forces, dia bukan hydrogen bond. Kalau kita sebut pasal carbon, sebab ni kan dia punya carbon banyak, CH3, CH2, CH2 and so on. Kita tahu kalau C dengan H sahaja, dia punya types of intermolecular forces dia adalah van der Waals forces. Okay, So lagi banyak bilangan carbon atoms, lagi tinggi dia punya boiling points because dia punya contact surface area dia tinggi ataupun dia punya molecular size dia tinggi. Okay, molecular size dia besar sebabkan dia punya van der Waals forces pun akan jadi lagi stronger. Okay, so that's why pentanoic acid ni dia punya boiling point dia is the highest. Okay, just because of hydrocarbon C dengan H ni, dia punya intermolecular forces, van der Waals forces ni bertambah stronger. It's just because molecular size tu bertambah besar. Okay, so more energy is required to overcome the stronger van der Waals forces in pentanoic acid compared to metanoic acid yang ada satu sahaja carbon atom. Bukanlah carbon atom sahaja lah, satu sahaja carbon. Yes. Okay. Hence, the boiling point increases when the molecular size increases. Okay, you nak terangkan macam ni pun boleh. You nak terangkan yang sebaliknya mengikut metanoic acid ni pun boleh. Tapi cumanya you kena bagi tahu lah kalau metanoic acid molecular size dia paling kecil, contact surface area dia paling kecil, van der Waals forces dia paling lemah. So, senang nak overcome the forces between them. That's why dia punya boiling point dia paling rendah. Okay. Okay, next example, dia suruh kamu susun ethanoic acid, butane and propanol in descending order of boiling point and explain. Okay, kat sini kita tengok kita ada three different organic compounds with different intermolecular forces between them. Because why? Kita ada kat sini carboxylic acid, okay, and we have alkane dekat butane. Lepas tu kita ada alcohol. Okay, kita tahu carboxylic acid dia ada stronger types of intermolecular forces, which is ada stronger hydrogen bond, just because of dia boleh buat hydrogen bond through dimerization. Alcohol pun dia ada hydrogen bond type of intermolecular forces. And then intermolecular forces of alkane pula ialah van der Waals forces, which is yang paling lemah sekali. Dia suruh kamu susun in order of descending kan, menurun. Kiranya mesti you kena susun daripada boiling point yang paling besar ke boiling point yang paling kecil. Okay, so macam mana nak buat tu? So kita tahu pentanoic acid ni dia ada stronger type of intermolecular forces and dia punya boiling point dia paling tinggi, so dia jadi kat depan sekali lah. And then yang paling kecil, boiling point paling kecil adalah butane because dia ada van der Waals forces sahaja. Okay, so please take note bila you nak susun, kena make sure your mathematical punya expressions ni kena betul ya. Ini adalah simbol mathematical expressions yang lagi besar. Okay, so you kena guna pentanoic acid lagi besar daripada propanol, lagi besar daripada butane. This is how you susun dia punya order. Kalau you buat terbalik akan jadi salah because soalan dah minta descending order. So mesti daripada besar ke kecil. Kalau ascending order, tukar kecil ke besar. So you have to be alert with the questions. Okay. And then next, you suruh kamu explain. Macam mana nak explain? So you boleh bagi tahu yang both pentanoic acid dengan propanol ni, kedua-dua mereka ada intermolecular forces yang sama, which is hydrogen bond. Okay, dua-dua boleh buat hydrogen bond between molecules. Tapi apa yang specialnya kat sini adalah pentanoic acid, dia punya hydrogen bonds ni lagi kuat. Sebabkan kenapa? Because pentanoic acid dia boleh buat stronger hydrogen bonds through dimerization. Okay, ayat ni sangat penting. Dia boleh form stronger hydrogen bonds through dimerization. Ayat ni sangat penting ya, dicari-cari oleh examiners kalau let's say keluar soalan yang macam ni lebih kurang. Okay. So kenapa carboxylic acid ni dia boleh form stronger hydrogen bonds compared to alcohol through dimerization? Inilah yang menyebabkan hydrogen bond of carboxylic acid ni lagi special compared to alcohol. Okay, although dua-dua ni ada sama intermolecular forcesnya. Okay, and then next kita ulaslah pasal butane pula. Okay, butane ni kita tahu is a non-polar molecule and the type of intermolecular forces of butane ni hanyalah weak van der Waals forces. Okay, so since there are weak van der Waals forces, less energy is needed to overcome the weak intermolecular forces in butane. Therefore, that's why lah butane ni dia punya boiling point is the lowest. Okay. Okay, the next physical properties of carboxylic acids that you need to know adalah solubility in water. Bila kita bercakap pasal solubility in water, ingat lagi tak? The organic compound will be only soluble in water if only dia ada hydrogen bonds. If only dia boleh form hydrogen bonds with water, because water pun dia ada hydrogen bonds. So only hydrogen bonds boleh soluble in hydrogen bonds. Since kita tahu carboxylic acid ni dia ada hydrogen bond, okay? So dia bolehlah tenggelam dalam water. Cumanya only the part of C double bond OOH ni sahaja, okay? Because kita tahu functional group C double bond OOH ni dia ada hydrogen bond. Okay, this one. Dia ada hydrogen bond. Tetapi the alkyl group yang attached pada hydrogen bond tu dia tak boleh soluble in water. Okay, sebab dia ada van der Waals forces. Okay, alkyl group kan dia hydrocarbon. Dia consist of carbon dan juga hydrogen. So carbon dengan hydrogen ni dia ada types of intermolecular forces, van der Waals forces. C double bond OH je yang soluble in water just because of the other type of intermolecular forces. Dia apa? Hydrogen bond. Okay. So this will be the hydrophilic area. Hydrophilic area ni maksudnya dia love water. Okay, hydrophobic area ni maksudnya dia phobia dengan air. Dia tak suka air. Because kenapa? Dia punya type of intermolecular forces dia van der Waals force. As what I told you, the organic compounds will only soluble in water kalau dia boleh buat hydrogen bond dengan air. Hydrogen bond, H2O kan ada hydrogen bond. So hydrogen bond dengan hydrogen bond. Kalau van der Waals forces tak ngam dengan hydrogen bond. So tak boleh tenggelam dalam air. Okay. Tapi as the number of carbon atoms increases, kiranya kita akan memperbesarkan lagi dia punya hydrophobic area. Okay, therefore the solubility pun akan berkurang. So kalau let's say you ada straight chain carboxylic acids ataupun aliphatic carboxylic acids with carbon yang more than 5, okay, contohnya lah kalau you ada starting daripada pentanoic acid dan ke atas, ya, pentanoic acid and above, dia dah tak soluble dalam water dah. Sebab kenapa? Because dah banyak sangat dah hydrocarbon ataupun hydrophobic area. Okay, so dia lagilah susah nak soluble in water. How about the aromatic carboxylic acids? Okay, aromatic carboxylic acids are slightly soluble in water at room temperature due to the huge aromatic ring. Okay, dia slightly soluble juga sebabkan kita tahu kalau let's say benzene ring dia ada C6H5 yang melekat pada COOH ni. Okay, dia ada hydrocarbon jugalah, kiranya van der Waals forces lah. So dia pun ada bigger hydrophobic area, so they will be slightly soluble in water at room temperature. How about dicarboxylic acids? Kalau let's say you ada organic compound yang ada dua carboxylic acids, okay, contohnya lah kalau let's say you ada cyclopentane, lepas tu ada COOH, ada COOH, dicarboxylic acid lah tu kan, are more soluble in water. Sebab kenapa? Dia banyak hydrophilic area. So bila banyak hydrophilic area dia besar, so dia bolehlah form hydrogen bond with water molecules lagi banyak. So that's why kalau let's say organic compound tu dia ada lagi banyak carboxylic acids, lagi dia boleh tenggelam dalam air sebab dia boleh buat hydrogen bond bersama dengan H2O, dengan air. Okay, so let's look at the first example. Dia suruh kamu compare the solubility of the carboxylic acids with molecular formula C5H10O2. So basically, this is a general formula and dia boleh buat few isomers of C5H10O2. Okay, Di mana kat sini kalau let's say you buat yang normal punya, you akan dapat normal pentanoic acid lah, CH3, CH2, 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 COOH. Okay. Tapi kalau let's say you buat chain isomers, you lagi pendekkan dia punya bilangan carbon atoms. So you dapatlah macam ada macam ni ke, atau macam ni. Okay. Tapi kesemua-semua structure ni adalah C5H10O2, and after that barulah dia susun. Okay. Dia susun dia punya solubility kat sini. We can see here the straight chain. This is a straight chain pentanoic acid. Okay. This is a straight chain pentanoic acid. Okay. Lepas tu look at the arrow. Dia punya mathematical expression ni. Straight chain pentanoic acid ni dia lagi kecil dia punya solubility compared to this kind of structure, compared to this kind of structure, and compared to this kind of structure, di mana kita lagi compactkan dia, kita lagi kecilkan dia punya bilangan carbon atom as the parents, and ada substituents yang banyak sikit lah. Okay, so basically this one, straight chain pentanoic acid ni, dia punya solubility lagi rendah. Sebab apa ya? Sebab dia ada biggest hydrophobic area. Okay, so you can see here, this is the hydrophilic area. Hydrophilic ni maksudnya yang sukakan air. Okay, so I'm going to highlight this one. Okay, this is the hydrophilic area, and this is the hydrophobic area. Sangat besar, and also dia punya contact surface area dia pun besar. So that's why dia insoluble. Meskipun dah tadi dekat dalam previous slides, I already told you guys yang kalau pentanoic acid, dia terus jadi insoluble in water. Straight chain pentanoic acid lah. Sebab kenapa? Sebab dia ada biggest hydrophobic area. Hence, dia paling tak soluble, paling least soluble. Okay? Manakala 2,2-dimethyl propanoic acid. This is 2,2-dimethyl propanoic acid. Is a very compact molecule. Dia paling banyak branch lah. Ada 2 branch and very compact. So again, this is the hydrophilic area, and the hydrophobic area ni dia dah dikompactkan. Dia punya hydrophobic area ni kecil saja. So branch molecules dia lagi compact. So that it is easier to form hydrogen bonds between with water molecules. So that's why, okay, this structure, this 2,2-dimethyl propanoic acid ni is the most soluble in water. Okay, sebab kenapa? Because dia punya hydrophobic area ni dah jadi compact compared to the straight chain pentanoic acid. Okay, so the last physical properties of carboxylic acids that you need to know is about dia punya acidity. Dah nama pun carboxylic acids kan. So macam mana you nak compare the acidity of carboxylic acids if given alcohol ataupun phenol. Okay, kita tahu alcohol ni dia ada acidity dia sendiri, phenol pun dia ada acidity-nya sendiri. Tapi when it comes to carboxylic acids, is actually carboxylic acids ni dia punya acidity dia paling tinggi compared to phenol dengan alcohol. Okay, disebabkan oleh dia boleh buat resonance stabilization of the carboxylate ion. Okay, kalau let's say dalam soalan tanya kenapa carboxylic acid ni dia punya acidity dia paling tinggi compared to phenol dengan alcohol, you boleh gunakan this point because dia boleh buat resonance stabilization of the carboxylate ion. Okay, macam mana buat tu? Macam ni lah lebih kurangnya. Kalau let's say you tak reti nak buat guna ayat, you nak terangkan dalam bentuk macam ni pun boleh, tapi you have to make sure you got it right. Okay, you lukis dalam kurungan macam ni, lepas tu lukis carboxylic acid tersebut, macam mana dia buat resonance, di mana this is the carboxylate ion, RC double bond OO minus, the negative sign here dia akan buat resonance. Kat sini dia akan berpindah dia punya double bond daripada kat bawah ni ke atas ni. Okay, so untuk show the resonance structure, you have to use this resonance arrow. Okay, so this is the resonance effect of carboxylate ion. This is the main reason why carboxylic acid is the most acidic sebab dia boleh buat, dia ada resonance effect of the carboxylate ion. Okay, basically the electrons in the carboxylate ion are delocalized between two oxygen atoms. Okay, ni pun penting ni. The electrons in the carboxylate ion are delocalized between two oxygen atoms. Okay, so ni pun point yang penting juga. Lukisan ni pun penting kalau you tak kerti nak terangkan by words. Okay, so inilah the main reason why carboxylic acid ni is the most acidic organic compound. Okay, carboxylic acid is more acidic than the phenol and alcohol disebabkan oleh inductive effect of the carbonyl group juga. Apa tu inductive effect? Okay, the carbonyl group ni lah, ni dia C double bond O ni. Okay, carbonyl group ni dia adalah electron withdrawing group. Okay, so electron withdrawing group yang attached to a carboxylate ion will delocalize the negative charge on the oxygen atom. Tadi kita dah nampak kan dia punya delocalization on the two oxygen atoms kat sini, satu lagi kat situ kan. So since that dia ada this kind of inductive effect sebab ada carbonyl C double bond O ni kan, dekat the carboxylate ion ni, so dia akan reduce the electron density of the OH and dia akan weaken the OH bond. Kerana because of this carbonyl group dekat C double bond O OH ni, okay, this is electron withdrawing group. Okay, this is electron withdrawing group, so dia akan weaken the bond between the OH. Okay, so the carboxyl hydrogen can lose proton easier. So since that dia boleh weaken the OH bond ni, so dia boleh lose the proton. This is the proton yang we are talking about. So dia boleh senang-senang nak hilangkan H ni dengan mudahnya. Just because of what? Because of dekat C double bond OH ni, this carbonyl C double bond O dekat this carboxylic acid, dia adalah electron withdrawing group and dia boleh senang nak delocalize the carboxylate ion between two oxygen atoms, so dia akan weaken the OH bond, so dia senang nak lose the proton easier. Okay, and the substituent groups yang attached to the carboxyl carbon will affect the acidity of the carboxylic acid. For example, kalau let's say, okay, substituents of this, contohnya R ni lah, R ni adalah AWG. So dia lagi suka lah. Okay, dia lagi suka. Kalau let's say kita gantikan dengan electron donating group, dia tak suka. Okay, electron withdrawing group dia akan stabilizekan the carboxylate ion. Contohnya kalau let's say dia dah jadi C double bond O minus, lepas tu kalau dia melekat dengan electron withdrawing group, it will be much better. Contohnya kalau dia melekat dengan halogen ke ataupun dia C double bond O ke, is much better because dia akan reducekan the electron density of the OH. So senanglah dia akan weaken the OH bond, dia akan increasekan the acidity. Okay, tapi kalau contohnya your carboxylic acid melekat dengan alkyl ataupun aryl group ni ialah contohnya benzene ring kan, itu adalah electron donating group. So you have to remember, carboxylate ion sangat tak suka dengan electron donating group sebab dia akan destabilize the carboxylate ion. Sebab dia akan increasekan the electron density of OH, so susah dia OH ni nak buang proton tersebut, so dia akan decrease the acidity. So in this case you always need to remember, okay, kalau jumpa carboxylate ion, you need to make sure dia melekat dengan AWG sebab the main reason here is we want to weaken the OH bond supaya senang nak lose proton. Kalau dia senang nak lose proton, dia punya acidity pun akan increase. Kalau dia susah nak lose the proton, dia punya acidity will be decreased. Okay, okay, tadi kita dah bagi tahu kalau let's say your carboxylate ion dia ada kehadiran electron withdrawing group. Contoh electron withdrawing group ni adalah carbonyl C double bond O ke ataupun halogen group. So kalau dia ada banyak kehadiran halogen group, lagilah dia punya acidity akan jadi tinggi. So for example, as you can see here, this is a normal carboxylic acid with a alkyl group sahaja, CH3COH, dia ada langsung EWG. EWG ni adalah electron withdrawing groups. So dia punya pKa jadi tinggi. Kalau pKa tinggi maksudnya is a very weak acid. Kenapa weak acid? Sebab dia susah nak lose proton. Okay, susah nak lose proton. So bila susah nak lose proton, jadinya dia punya acidity pun akan berkurang. Okay, but what if I letak satu electron withdrawing group kat sini, Br. So dengan kehadiran Br ni actually dia membantu untuk weaken the OH bond here, untuk lose the hydrogen proton, the proton here. So that's why dia punya acidity tinggi sikit lah ya. Compared to big Cl, kalau tak Cl pun dia pun acidity makin tinggi. Kalau tak F ni dia punya electronegativity lagi tinggi. We know that F is the most electronegative atom. Okay, so that's why lah dia memainkan peranan jugalah. So that's dia punya EWG in F ni halogen, jenis halogen yang electron withdrawing group yang macam kuat sikit lah. So that's why you can see here dia punya pKa value dia lagi rendah. So that means it's a stronger, dia punya acidity tu lagi kuat, stronger acid compared to ClCH2COH and BrCH2COH. But what if I tambah another Cl? If I tambah another Cl, dia punya acidity akan lagi kuat. I tambah lagi satu Cl, lagi kuat sebab dia ada banyak electron withdrawing group. Electron withdrawing group apa contohnya? Contohnya halogen, as what we have discussed previously. Okay. Okay, so the negative effect akan decrease if the substituent is farther from the carboxyl group. Okay, for example, okay, although Cl ni adalah electron withdrawing group, we know that Cl ni adalah electron withdrawing group. Tapi kalau let's say dia jauh dengan COOH, dia punya distance-nya jauh, okay, maka dia punya acidity pun takkanlah tinggi sangat. Okay, and then contohnya kalau tengok in this one, okay, distance between this electron withdrawing group dengan carboxylic acid ni makin lama makin dekat. Dekat sikit. Kalau dekat sikit, dia punya acidity pun akan jadi lagi tinggi sikit. Okay, what if I dekatkan lagi kedudukan electron withdrawing group dengan si double bond OH ni, lagilah dia jadi stronger acid. Sebab kenapa? Sebab dia punya distance makin dekat, so senang nak weakenkan the bond between O dan H, senang nak lose proton. Okay, sebab senang nak lose proton. You kena ingat acid kan is all about losing a proton. So kalau lagi senang dia nak lose proton, lagilah dia punya acidity dia tinggi. Tapi dalam faktor carboxylic acid ni, kalau EWG ni ada, maka senang nak lose proton. Okay, selain daripada kita banyakkan electron withdrawing group dekat carboxylic acid, faktor distance pun memain peranan. Okay, distance between EWG dengan carboxylic acid pun memainkan peranan. Sebab kenapa? Makin dekat electron withdrawing group dengan carboxylic acid, makin weaken lah, makin senang lah dia nak lemahkan bond between O dan H ni. So lagi senang nak lose proton, makanya dia akan jadi a stronger acid. Let's look at this example. Dia suruh kamu explain kenapa carboxylic acids are stronger acids compared to phenol and alcohol. Okay, kalau macam ni tak ada masalah sangat. Sebab kita tahu carboxylic acid is the strongest acid just because dia boleh buat resonance between two oxygen atoms. Okay, so you boleh terangkan melalui dua cara. Sama ada you write down dia punya macam mana dia menghasilkan lepas dia lose proton tu dia menghasilkan apa, conjugate ion dia, Okay, ataupun lagi satu dengan cara you terangkan melalui ayat saja. Okay, so kita tengoklah the first solution di mana kita write the acid dissociation equation untuk carboxylic acid, phenol dan alcohol. Macam mana you nak write down the acid dissociation equation? You need to remember kalau let's say acid dia punya proton mesku. Okay, so you kena macam mana nak draw dia punya produk tu, you kena nilah tahu mana satu proton yang dia nak let go. Okay, contohnya carboxylic acid, kita tahu kita kena let go the proton between this oxygen dengan hydrogen untuk dia menghasilkan carboxylate ion. Okay, kalau phenol pula dia akan lose proton between this oxygen dengan hydrogen untuk menghasilkan phenoxide ion. Kalau alkohol pula dia akan lose the proton between this oxygen dengan hydrogen untuk menghasilkan alkoxide ion. Okay, so once you tahu, you dah write down dia punya produk yang correct. Untuk carboxylic acid dia menghasilkan carboxylate ion, untuk phenol dia menghasilkan phenoxide ion, untuk alkohol dia menghasilkan alkoxide ion. Kalau you write down ketiga-tiga correct acid dissociation equation for each of them, dah memadai. Okay, tapi kalau let's say you tak reti, you terangkan guna ayat. Let's look at the next solution pula. Okay, the next solution, kalau you tak reti nak lukis yang proper, yang betul-betul the correct product after the acid dissociation, okay, you boleh juga explain guna ayat. Okay, tapi you kena explain the stability of the conjugate base yang dihasilkan. Okay, no need to write the acid dissociation formula again like previous. So sama ada you buat yang solution yang pertama atau solution kedua, dua-dua ni akan dapat markah. Cumanya kalau let's say solution yang pertama tu, kalau let's say you hafal dan tahu macam mana nak write the acid dissociation formula, dah itu je lah. Kalau tak, you kena terangkan. You kena terangkanlah satu persatu. Kita tahu yang carboxylic acids are more acidic due to the resonance stabilization of the carboxylate ion. Okay, ni penting Due to the resonance stabilization of carboxylate ion. So, you kena terangkan lagi sikit. Apa tu? Resonance stabilization of the carboxylate ion. Sebab the electrons in carboxylate ions are delocalized between two oxygen atoms. Okay. This is the backup penerangan yang untuk resonance stabilization of the carboxylate ion. Okay. Lepas tu you terangkanlah sikit lagi. The carbonyl group in carboxylic acids adalah electron withdrawing group yang akan reduce the electron density of the OH. Therefore, the OH bond akan become weaker, so they're easier to lose the proton. Okay. So the proton, the H in the OH bond of the carboxylic acid is easily dominated. Therefore, carboxylic acid is more acidic than phenol. Okay, manakala untuk phenol dia akan menghasilkan phenoxide ion. Okay, so the electrons are delocalized inside the benzene ring. So untuk phenol pula you kena bagi tahulah dia menghasilkan conjugate base apa. Dia akan menghasilkan conjugate base phenoxide ion, and also you need to tell dia punya stability of dia punya conjugate base, which is we know that phenoxide ion ni dia ada stability of conjugate base dia adalah bila electrons tu delocalize inside the benzene ring. Alright. How about alcohol? Okay, alcohol dia akan menghasilkan conjugate base alkoxide ion. So apa yang you boleh cakap kat sini ialah alkoxide ion ni is unstable just because of the presence of electron donating group. Okay. Sebab kalau kita tengok structure previously, alkoxide ion kan, contohnya this is alcohol. If this is alcohol, lepas tu kalau dia buat acid dissociation constant, dia akan dapat RO pluskan dengan H plus lah. For example, kalau let's say you tambah dengan water, jadilah H3O plus. Tapi ni kalau tak ada water, dia jadi macam ni kan. Okay, kat sini, dia jadi unstable. This alkoxide ion is unstable just because of ada alkyl group sahaja. Dia ada electron donating group yang directly attached pada this alkoxide ion. So that's why the unstable dia jadi less acidic. Faham? Let's look at the last example. Dia cakap between both compounds, which one is more acidic? And explain your answer. Okay, kat sini, this is the COOH, okay. C double bond OH. This is the functional group carboxylic acid that we are talking about. And then, kita tengoklah dekat kedua-dua ni apa yang berbezanya. Kat sini, dia ada melekat dengan electron withdrawing group jenis fluorine. Okay. And then yang this one pula dia melekat dengan electron withdrawing group jenis chlorine. Okay. So previously I already told you guys between carboxylic acids yang melekat dengan electron withdrawing group fluorine dengan chlorine, yang melekat dengan fluorine ni dia punya pKa value dia lagi lagi rendah sebabkan dia jadi stronger acids. Okay. Because why? Because F is more electronegative compared to Cl. So the solution here, bila disuruh kamu compare between each of these compounds, which one is more acidic, so you can answer 2-fluoropropanoic acid is more acidic. Penting tau mathematical expression ni, more acidic compared to 2-chloropropanoic acid. So bila disuruh kamu explain, you can say that both F dengan Cl ni adalah electron withdrawing groups. Okay, kita kena tahu carboxylic acid love electron withdrawing groups. Okay, they love electron withdrawing group. Tapi, kena tengok juga electron withdrawing group tu macam mana. Macam fluorine, dia punya electron negativity dia lagi tinggi compared to Cl. Because as we know, memang fluorine ni dia punya is the most electronegative atom in the periodic table of elements. Hence, fluorine dia akan withdraw the electron better than Cl. Okay, so that's why fluorine ni dia akan stabilizes the carboxylate ion more than Cl. Okay, so that's why lah 2-fluoropropanoic acid ni is more acidic compared to 2-chloropropanoic acid.